For question 25, we have an electron which is initially traveling horizontally at 1.97 times 10 to the power of 7 meters per second, and this electron enters a uniform E field at right angles to the field. The electric field is generated by applying a potential difference of 3 volts between two parallel conducting plates which are 10 centimeters apart. So the first thing that I want to try to figure out is what is the electric field strength. Okay, and we know that the electric field strength, or the magnitude of the electric field strength, is going to be equal to delta V over delta D, right? So our potential difference is 3 kilovolts, which is 30,000 or 3,000, divided by my distance between the parallel plates, which is 10 cm, which is 0.1 meters. And if we solve for this, we have 30,000 volts per meter. Okay, so the next thing is, what is the acceleration of the electron? Okay, we know that F is going to be equal to E times Q, all right, and this electric force is going to provide my net force, so it's going to be equal to MA. So as such, A is equal to EQ over M. So if I just substitute in the values for Q for my electron, which is 1.6 times 10 to the power of minus 19 coulombs, divided by the mass of the electron, which is 9.11 times 10 to the power of negative 31, we get a value of 5.2689 times 10 to the power of 15 meters per second square. Okay, so from here, bear in mind that this is the y acceleration. This is the y acceleration. So from here, they tell us that we have the electron which traveled 5 cm horizontally into the field. So the time taken for it to traverse this 5 cm is going to be 0.05 divided by 1.97 times 10 to the power of 7. Okay, so pressing our calculator to find the amount of time, we have 0.05 divided by 1.97 times 10 to the power of 7. We have 2.5381 times 10 to the power minus 9 seconds. Okay, so from here, this becomes a kinematics question, because if they want to find out the vertical displacement, we write down our SUVAT, okay, SUVAT, okay, and we have the acceleration, which is 5.2869 times 10 to the 15, okay, and we have the time, which is 2.538 times 10 to the negative 9 seconds, and our initial y velocity is going to be 0, and we want to find our delta h, which is essentially our sy. Okay, so delta h is going to be half at square. So we have half times 5.2689 times 10 to the 15 multiplied by 2.538 times 10 to the negative 9 square, and this should give us a value of 0.016970726. Okay, and this answer is going to be B.